Hey guys, today we're going to be looking at the second part of the Pythagorean theorem. The first part for today is looking at, they're going to give you three measurements of a triangle, which could possibly be a right triangle, but we don't know. We're going to tell them. So if you read the instructions, it says, tell whether the following could represent sides of a right triangle. So if they do represent the sides of a right triangle, then the Pythagorean theorem will work out. It'll be satisfied. So you basically have to test, does a squared plus b squared equal c squared? So you take the three measurements, and the way you figure out which ones are a, b, and c to plug into the formula is that the longest side will be c. Longest side, the hypotenuse, will be c, because the diagonal is always the longest. So in this example, c would be 30 inches, and then a and b could be either or. And you just plug them into the formula to see if it works out to be true. If it works out to be true, then these do represent the sides of a right triangle. If they doesn't come out to be true, then it's some other type of triangle, but not a right triangle. So I'm going to plug in 10 squared plus 20 squared to see if that equals 30 squared. So 100 plus 400, does that equal 900? No, 500 does not equal 900, and so therefore it's not a right triangle. Okay, so you guys can try example 2 on your own. Again, c would be the longest side, and these would be a and b. So I'm going to go into a squared plus b squared equals c squared, and plug in 14 squared plus 24 squared. Does that equal 26 squared? So 14 squared is 196, and 24 squared is 576, and 26 squared is 676. So 576 and 196 do not equal, so this is again not a right triangle. So in both examples it was not a right triangle, but if it had come out to equal the same number on both sides, then we would say it is a right triangle. Okay. Example 3 is, now we're looking at word problems. A rectangular soccer field measures 90 meters wide and 120 meters long. The coach asks the players to run from one corner to the corner diagonally across the field. How far do the players run? So if you have a rectangle and you go from diagonal to diagonal, you're now creating a right triangle here. So you can use the Pythagorean theorem on rectangles if you're looking at the length of the diagonal with the two dimensions of the rectangle. So it measures 90 meters wide and 120 meters long. Those are the outside measurements of the rectangle, the length and width of the rectangle. And we want to know how far do the players run diagonally across the field. We're looking for the hypotenuse of the right triangle, C. Okay, so it's like we're doing this. 90, 120, and we're looking for C. So we're going to use a squared plus b squared equals c squared, because it is a right triangle, and we're going to square 120 and square 90, and we're looking for the hypotenuse, so c is our variable. So when I square 120, I get 14,400. When I square 90, I get 8,100 equals c squared. I'm going to add 14,400 plus 8,100. I get 22,500 equals c squared. And then I'm going to take the square root on both sides, which is going to be 150. Square root, c equals 150. So the players ran 150 feet across the field, or meters rather, I should say. Okay. Another really common type of word problem is one where they talk about ladders leaning against buildings or houses. So examples 4 and 5, look at those types of problems. They're like the traditional, they're about ladders. The bottom of a ladder must be placed 3 feet from a wall. The ladder is 12 feet long. How far above the ground does the ladder touch the wall? So the one really important thing to remember is that the ladder leans. The ladder is always going to be your hypotenuse. It's the diagonal part of the triangle, and the house is the vertical part. So the bottom of a ladder must be placed 3 feet from a wall. So this is the bottom of the ladder. I'll do it in red. It must be placed 3 feet from the bottom of the wall. So this is 3. The ladder is 12 feet long. So that's the length of the ladder. That's this diagonal part, 12 feet long. How far above the ground does the ladder touch the wall? So they're asking us for this green section here, how far above the ground, directly, vertically. So remember, your hypotenuse is the ladder, c. So you're going to use a squared plus b squared equals c squared. And you're going to plug in 3 as either a or b, and then the 12 has to be the hypotenuse. It goes in the place of c. So we have 9 plus b squared equals 144. I'm going to subtract 9. I have b squared equals 135, and then I'm going to take the square root, and I should have told you round to the nearest, let's do 10th. And so you're going to take the square root of 135, and that'll give you, to the nearest 10th would be 11.6 feet, approximately. Okay, you might want to try example 5 on your own now, because it's kind of the same thing. How far from the base of the house do you need to place a 15-foot ladder so that it reaches exactly to the top of a 12-foot wall? So you could pause the video and try that on your own. The ladder leans. How far from the base of the house, so meaning the bottom of this part here, do you need to place the ladder? So that's x. The ladder is a 15-foot ladder. That's the length of the ladder. That's the hypotenuse, so that it reaches exactly to the top of a 12-foot wall. So they're talking about the vertical distance is 12 feet. So in this problem, when I plug, I don't know what that is. When I plug into a squared plus b squared equals c squared, I'm going to be using 15 for my hypotenuse, c. 12 can go for either a or b. And I'm solving for the other leg, a or b. So a squared plus 144 equals, and 15 squared is 225. I'm going to subtract 144 from both sides. I have a squared equals 81. Yeah, so take the square root, and it's a perfect square, so a equals 9. So you would have to place the ladder 9 feet from the base of the ladder from the wall. And then another type of problem that you might see is about people sort of driving in different directions and then finding their distance from each other. So in this problem, 2 cyclists start from the same location. One travels directly north for 9 miles and the other drives directly east for 12 miles. So one person goes directly north up for 9 miles and the other person goes directly east for 12 miles. And then how far apart are they? So this cyclist is here and this one is here. So the question is, what's their direct distance if you were to measure directly how far apart they are? And that is the hypotenuse of the right triangle. So it's a Pythagorean theorem problem. A squared plus b squared equals c squared. We're looking for c. So c is your variable. You're going to square 81. You're going to square 12. You get 144 equals c squared. We're going to add those up. I get 225 equals c squared. And then I take the square root on both sides like we did yesterday. And I get c equals 15. So the direct distance between the 2 cyclists after they drive or ride in those directions is 15 miles. Okay, and we'll talk about these in class today. All right, thanks.